Assalamu alaikum. By the end of this video, you will be able to understand definition of function, representation of functions, and types of functions. This is a lengthy video, but this understanding of this all these topics, you need time. Listen with patience and with concentration. Definitely you will understand all these things in detail. Let's begin. Functions. Understanding of functions is essential. In fact, everything in mathematics revolves around this. To understand the functions, we need the knowledge of sets, Cartesian product, and relations. I hope you know this. If not, watch the video Sets, Cartesian product, and relations in detail with Arabic translation. Link is available in the below description box. So understanding of these relations is very much important to understand functions. Okay, so if you are not aware of this thing, please watch this video. So what is functions? In mathematics, functions is basically something that relates or connects one set to another set with some some relation in a particular way, not all relations, some relation in a particular way, which helps us to describe, analyze, and use to make predictions. So we are going to understand this statement in detail now. What is this? So once again, something which relates or connects one set to another set with some relationship. So what kind of the spatial relationship we can see now in detail. Functions is a subset of relation, as just now I said, is a subset of relation, and it is written as f of x, and you have to read it as f of x, where x is the input value. Okay, so now what is f of x? It is a subset of relation. R is a relation here. This is the symbol of subset. You can see the Arabic translation. F of x is a subset of relation, and relation is a subset of Cartesian product. Now you understand this thing with a Venn diagram. See, this is for example a function. So function is a subset of relation, and relation is a subset of a Cartesian product. This is a brief idea about the functions. Let's proceed to understand the definition of functions. Function. It is a relation in which each possible input value leads to exactly one output value. It is a relation in which each possible input value leads to exactly one output value. This is the definition of function. So here input values are called domain and output values are called range. So let me understand this thing with a diagram. See here, let this be a function. It works like a machine, okay, where each input value leads exactly one output value. So try to understand, each possible input value leads to exactly one output value. So this is a function where we have some input value. Here we are giving input to the function, okay, and we will get output. So this function works like a machine. So here the input values are called domain and the output values are called range. So let me understand this with an example. See here. Well, to understand functions, consider function as fruit juicer. So here I will give 4 examples. Let me see the first example of it. Let this be a function, fruit juicer. I am considering as a function. Okay, consider function as a fruit juicer. So let this be a fruit juicer as a function. So here I will give an input value. Input here I am giving as a mango. Okay. So this fruit juicer makes a juice of mango, and the output you will get juice. Right? Okay. So let me consider one more example. Let this be a function machine. So here I am giving three different inputs, okay, to the juicer. So here also I will get one output only. Whether you will give one input or more than one input, but the output will be only one. Right? Output is only one. This is the definition of function. It is a relation in which each possible input value, whether it is one or more than one, leads to exactly one output value. Let me proceed to another example. Example 3. So here I am taking three different inputs which I am giving to the juicer. So but here the juicer is producing more than three outputs, three inputs and three outputs. Is it possible? Yes, you are right. It is not possible in normal machines. So let me see one more example. For example, here I am taking a fruit, an input, which I am giving to function, a juicer machine, but this machine is not giving output, not at all. It's taking input but not giving output. Is it possible? Yes, you are right. This is also not possible in normal machines. So please try to understand here. These two cases are not possible. These two cases which are not possible in functions. So that is, number of inputs may be one or more than one, but the output must be only one. More than one and not at all a output. These two cases are not possible in function. Well, I have taken these four examples to make you understand about the definition of function. However, representation of functions are different in mathematics. Now let me understand how these functions are represented in mathematics. That is the representation of functions can be represented as arrow diagram, roster form, graphical representation, and algebraic representation. So in this video, you are going to learn about arrow diagram, where you will learn how to identify a function. If it is a function, then how to find the domain, codomain, range, image, see the Arabic translations and make a note of it. And you are going to learn about pre-image and how to identify type of function. So another video is there for roster form and graphical representation, and also there is a video on algebraic representation. So link is available in the below description box. So watch after arrow diagram, you can watch the roster form, algebraic representation, graphical representation in another videos. So now let's understand arrow diagram. Arrow diagram. This representation indicates the mapping from one set of elements to another set of elements by using an arrow indication. Let me understand with an example. See, this is the example of arrow diagram where A maps to B is a function f, a relation f. So here you have to note that sets are denoted by capital letters A, B, C. So this is set A, this is a set B. So sets are denoted with capital letters like A and B, and functions and its elements are denoted by small letters A, B, C. Like this, the function f, which we denote by small letter, and its elements, these are the elements of the set A, so we denote it with small letters A, B, C. So now here this relation is a function, not a function. Just recall the definition of function. What it says, okay, every element every input must leads to exactly one output, right? But here the element A, it leads to two outputs, so that is 1 and 2. So just you recall the example 3. As per the example 3, so it is giving two outputs, then it is not a function, right? This relation is not a function. And moreover, if you recall the example 4 what it says, that if an element has no output, here input is there, set A elements all are inputs, okay, these all are inputs. So in the input B has no output, therefore it is also, because of this example 4 and example 3, if you recall, so because of this example 3 and example 4, this is not a function. So now let me understand by the definition or statement given by for an arrow diagram. What it says? In arrow diagram, every element of first set should associate with one and only one element of second set. Same thing is given in different way for arrow diagram. What it says, that every element of first set should associate with one and only one element of second set. Here the set A is associated with two elements, right? So therefore this relation is not a function. And also the other reason is set B, element B has no association, while every element of first set must have one and only one. So set element B has no relation. So because of these two reasons, this is not a function. So this example is not a function. So you have to understand one of the important question. So another one, you see an example. Here the function g, which maps from A to B. So see here, as per this definition of the arrow diagram, every element of first set, here the first set elements are A, B, C. Every element of first set should associate with one and only one element. So A has only association with only one element, and element B also has only one association, and C also has only one association, right? So therefore it is a function. It is a function. I hope you are understanding. This is a function. So another example you can see now. See here. Again see the statement which is given over here. Every element of first set, means here element C is missing. No association. So no need to see further. Okay. So here C has no relation. Therefore it is not a function. It is not a function. I hope it's clear for you. Another example you can see. Here function K, where set A maps with B. So here you see here whether all the complete statement satisfied. Every element of first set. So every element of first set A, B, C has association with only one. With only one. So of course set A, element A has only one relation. Element B has only one relation, right? Similarly C has also only one relation. So all this statement satisfies. Therefore it is a function. It is a function, right? Is it clear for you? So when this, and I hope you understood about the function and not a function. Now let me understand the domain, image and pre-image. So here I will take the example K, the function K, the last one here. So here just one by one we can understand the input values. The set elements are the input values. These are the input values. So domain is the input values. So here the input values are A, B, C, right? A, B, C are the elements. So here the domain is A, B, C. Domain for the function K is A, B, C is the domain. And codomain are the elements of the second set, set B, all the elements of the second set. So here what we have, the codomain values are 1, 2 and 3. These are the these are the this is the set of codomain. This is the set of codomain. That is 1, 2, 3 is the set of codomain. Now range. Range is the value. Range is the set which has only the association with the first set. Here AB has association with only one and C has association with only C. So this only 1 and C is the range. The output values are the range. The output value is only 1 and 3. So here the range is 1 and 3. Is it clear? Codomain is the all possible values, means the all elements of the set B is the codomain, whereas the range is the only output value. Range is the only output value. I hope it's clear, codomain and range for you. Now you see the image. Image is the Arabic translation for image, codomain and everything is in the, just previously go back, you can see it. So now here A, image of A, the associate, what is the image of A? That is 1, right? Or you can say f of A, both are 1. F of A or image of A means 1. Okay, not f of A, it should be k of A, sorry. It must be k of A, the function is k. So k of A is equal to 1. The next one is pre-image of A. Pre-image of A. What is the pre-image of A? Pre-image of A, pre-image of 1. Pre-image of 1 is A and B. Both are the pre-images, right? Pre-image of 1 is A and B. You have the two associations, right? So pre-image of A1 is A and B. Similarly, what is the pre-image of 2? Pre-image of 2? Pre-image of 2 is, there is nothing. No pre-image for the 2. So then it is a empty set, you can write. Or you can write like this, empty set. So pre-image of 2 is empty set. No pre-image for the 2. Okay. Let's we do an activity on this. If the following arrow diagram defines a function, then this is the given function which maps A to B, and these are the questions. Now pause the video and solve all these things right in your notebook and check one by one answer now. Okay, first pause the video. I hope you are doing. Okay, now see the answers here. What is the domain of F? Domain is the first set elements. The input values are the domain. First set elements are the domain. So domain of F is yes, A, B, C and D. These are the 4 elements of the domain. What is the codomain? Codomain are the all possible input values. The elements of the set B. Elements of the set B are the codomain. That is 2, 3, 5 and 7. All possible output values are the elements of codomain. Now range. Range is the output values. Output is only 2, 5 and 7. These are the output values. Okay, so 2, 5 and 7 is the range. That is 2, 5 and 7. These are the 3 elements for the range. Now what is f of b? F of b, this element, the association of b. What is the element? 5. F of b is equal to 5. Image of C, check the answers. I hope you got the same answers. Image of C or f of C, same thing. Image of C is also 5, right? Now pre-image of F, pre-image of 2. Pre-image of 2. What is the pre-image of 2? Pre-image of 2 is A. You are right. And now pre-image of 5. Pre-image of 5 are 2 elements. That is B and C. These are the pre-image of 5. And what about the pre-image of 3? Yes, it is empty set. No pre-image. Or you can write this symbol also. Okay, so pre-image of 3 is empty set. There is no pre-image for the element 3. Let me learn some more mathematical terminologies, that is different types of functions. One-to-one function, which is also known as injective function, onto function, surjective function, and one-to-one onto function is also known as bijective function. Let me start with one-to-one, which is injective function. It says that the statement for this one is elements of the codomain, that is the second set, are mapped to only one element of domain, only one element of domain. Okay, this statement make you confused, but don't worry, this example will make you understand. See here, let this be the function which maps from a to b. So in this one, what it says, the elements of the codomain. This is the codomain, right? 1, 2, 3. These are the three elements. It must map with only one element of domain. Here, if you see the element which is 1, which is mapped with two elements, that is A and B, right? This is the element A which is mapped with two elements A and B. So as per the statement, this is not one-to-one function. Not one-to-one function. Understanding? This is not one-to-one function. One more example. Function g which maps from a to b. Here the codomain elements are 1, 2, 3. Just to see the statement, 1 to 1, element of codomain and element of domain must have only one relation, 2 and b, c and 3, only direct 1 to 1 relation. So this kind of relation are known as one-to-one function. So this is one-to-one, right? Every element has only one relation, one-to-one function. This is one-to-one function because codomain of elements of function g, this is the function g, has only one relation, right? So 1 to 1, this is 1 to 1 function. I hope it's clear for you. See one more example. Function h which maps from a to b. Here the codomain elements are 1, 2, 3, right? So in this one, see the relation with 1 has only one relation, that is with c, and 2 has only one relation with b, and c has only one relation, that is with a. So it has only one relation. A one relation, b has only one relation, c has only one relation. So codomain elements 1, 2, 3 has only one relation. So codomain, that elements of codomain map to only one element of domain, then it is called one-to-one function. So this is also a one-to-one function. I hope it's clear for you. One-to-one function. Okay, this is also a one-to-one function, and this is one-to-one function, and this is not one-to-one function. Okay, three examples. I hope it's clear for you. Second type of function, onto function, is also known as surjective function. It says that every element of codomain are mapped at least one element of domain. Every element of codomain must map with at least one element of domain. This is about onto function. Let me understand with an example. Here the function f which maps from a to b. Here it says that every element of codomain must map with at least one element of domain. Here A has a pre-image, 3 has pre-image, 4 has pre-image, but 2 has no pre-image, right? It is not mapped with any of the element of first set, that is from the domain. So therefore it is not a onto function. I hope it's clear for you. This is not onto function. Let me see another example. Function g which maps from e to f. Here the second set elements, the codomain elements, are 1, 2 and 3. Here you see each element 1 is mapped with one element, 2 has map with one element, that is pre-image is D, and see here for the 3 has two pre-images, no problem, right? It says at least one, so more than one, no problem. So all the elements has the pre-image, all the elements of the codomain has the pre-image, therefore it is onto function, it is onto function, onto function. Now let me see one more example. Function h which maps from M to N. Here the codomain elements are 1, 2 and 3. Just check it here. These 3 elements has the mapping. At least one mapping, right? One has the pre-image is C and 2 has the pre-image is B, and for the 3 the pre-image is A. So all the elements has at least one pre-image, so therefore it is onto function. So this is also a onto function, right? So now let me see one more type, the last type of the third type of function, that is bijective function. It says that functions that are both 1 and onto are the bijective functions. Let me see this with an example. So first recall the 1 function. What it says, elements of codomain are mapped to only one element. Okay, elements of codomain are mapped to only one element is the one-to-one function, and onto function says that every element of codomain, every element of codomain map to at least one element of domain. So now let me see here example. Let f be a function which maps A to B. See the codomain elements. See the codomain elements. Here 1 has a pre-image, 3 has pre-image, 4 has pre-image, and every element of codomain are mapped to only one element, and 3 is mapped to only one element, 3 is mapped to only one element, 4 is also mapped to element. Whatever it is mapped, this all elements are mapped to only one element. 2 has no mapping, no problem, but the elements which are mapped which only to one element, therefore it is one-to-one function but not onto, therefore it is not bijective, not bijective, because it is not onto. Onto says that every element must map, but 2 is not mapping, therefore it is not onto, implies it is not bijective. Okay, it is not bijective. So let me see the another example. G is a function which maps from E to F. Here see the elements of the codomain. Here 1 has only one pre-image, 2 has only one pre-image, but 3 has two pre-images, that is B and C. Therefore it is not one-to-one function. One-to-one says that map to only one element of domain, but 3 is mapped to two elements. It is onto. Onto says every element of codomain are mapped. So every element of codomain are mapped. It is onto but not 1. Therefore it is not bijective. It is not bijective. It is onto but not 1. Okay, it is not bijective. Not bijective. Okay, so now one more example. Function h which maps from M to N. See the elements of the codomain elements which are 1, 2, 3. All 3 elements has only one mapping, one pre-image. 1 has one pre-image, 2 has one pre-image, 3 has only one pre-image, therefore it is one-to-one function. What about onto? Every element of codomain are mapped. So all the elements are mapped, at least one, right? So it is 1 and onto, therefore it is a bijective function. It is a bijective function. Right? Understanding? The first one is 1 function, 1-to-1, but not onto. Therefore it is not bijective. The second function example, it is onto but not 1-to-1, but not 1-to-1. but not 1 to 1. Therefore, it is also not a bijective function. This is 1 1 and onto both. It is 1 1 and onto. The third example is 1 1 and also onto. Therefore, it is a bijective function. Third example is a bijective function. So let me end this video with doing an activity on types of function. So identify the types of function in the following. The very first one example is function f which maps a to b. Here you see the codomain. We need to identify the type of function. Which type of function? 1 1 onto or bijective. So here 1 has only one preimage, 2 has only one preimage, 3 has only one preimage, but 4 has no preimage. So the elements which has the image only 1 1. Therefore it is 1 to 1 function. It is 1 to 1 function. Okay, not onto. It is only 1 to 1 function because 4 has no preimage, therefore it is not onto. So one more example. Function g which maps e to f. Here the codomain elements are 1, 2 and 3. So see here, first 1 has only one preimage. Okay, 2 has two preimages, that is b and d. B and d are the two preimages, therefore it is not 1 to 1. But all the elements of codomain has a preimage, at least one preimage, therefore it is onto function. This is onto function. This is onto function. This is onto function because all the elements of the codomain has at least one preimage, therefore it is onto function. One more example. Function h which maps from m to n. These are the codomain elements. So 1 has one preimage, 4 has one preimage, 9 has one preimage, 16 also has only one preimage. All the elements has preimage and that is only one preimage. So therefore it is 1 to 1 as well as 1 to 1 and onto, right? 1 to 1 and onto. Therefore it is a bijective function. 1 1 and onto both are here, therefore it is a bijective function. Let me see one more example. Example 4. This is a function z which maps from x to y. So the elements of codomain of this function are p, q, r, s and t. P has only one preimage, q has only one preimage, s has no preimage, r has only one preimage, and t has only one preimage, but s has no preimage. The elements which has the preimage all 1 1, but s has no preimage, therefore it is not onto, but this is 1 to 1 function. 1 to 1 function. It is a 1 to 1 function. Okay, now let me see one more example. Here the function f which maps a to b. Here the function f maps a to b. 1 has a preimage, that is only 1. 2 has two preimages, therefore it is only onto. All the elements has the preimage, therefore it is onto, not 1 to 1. This is the last example in arrow diagram. See here the function z. These are the codomain elements of the function. So in this one, p has two preimages, so it is not 1 to 1. But q and s has no preimage, so this is not onto, not 1 1, not onto. So this function is neither 1 1 nor onto, not 1 1, not onto. This function is not 1 1, not onto. Okay, so there can be a function which is not 1 to 1, which is not onto also. I hope all these things are clear for you. So this was about the arrow diagram representation. So everything is clear for you. These were the basics of functions. and I hope you understood. To go more deep into the functions, watch the videos roster form and graphical representation of functions, algebraic representation of functions, composition of functions. Link is provided in the below description box. Thanks for watching. Have a nice day. Masalam.